What if a sophisticated civilization existed on our planet before us? Uncover the Silurian Hypothesis, a bold concept that compels a reevaluation of Earth's entire history. We'll delve into the abyss of ages, comprehending how profound time can obliterate any trace, transforming great cities into geological dust. Drawing upon our own imprint in the Anthropocene epoch, we'll learn to seek out subtle shadows, anomalous isotopes, implausible minerals, even ancient space debris, potentially messages from a distant past. Applying the Fermi paradox not to far-off stars, but to our own history, we'll ponder why Earth seems silent. Perhaps we'll discover the Great Filter, a temporal trap our predecessors may have already traversed. Prepare to view our planet through completely new eyes. Prepare to recognize humankind as possibly just an echo of a far older song. Each civilization, like a child gazing in a mirror, sees itself at the center of a unique and singular world. Humans are no exception. Our history, our achievements, our place on this planet, all seem the pinnacle of evolution, the culmination of billions of years of cosmic drama. We explore the cosmos in search of life, hoping to find kindred spirits, certain that in our own home, Earth, we were the first to build cities, invent technologies, and leave an indelible mark. But is this truly the case? Gaze into the unfathomable expanse of geological time. 4 billion years. This figure is so vast that our minds struggle to encompass it. Human civilization, in its technological sense, has existed for only a few centuries and written history for only a few millennia. It's a fleeting spark against the backdrop of endless epochs. This is where history takes a sharp turn. What if, long before the first humans, long before the dinosaurs departed the stage, or even much earlier, intelligent beings walked the Earth, capable of building, creating, and transforming their planet? This provocative idea lies at the heart of the so-called Silurian Hypothesis, proposed in 2018 by two distinguished scholars, astrophysicist Adam Frank and climatologist Gavin Schmidt. Their aim wasn't to prove the existence of ancient aliens. Rather, they posed a fundamental question. If a technologically advanced civilization existed on Earth, say 50 or 100 million years ago, what traces might it have left behind? And more importantly, could we detect these traces today? Official science, of course, is skeptical, citing the complete absence of archaeological evidence. No ancient pyramids, no sunken cities, no tools carved from stone from the dinosaur era. This argument, seemingly irrefutable, suggests that the lack of archaeological finds, by conventional standards, implies the absence of the civilization itself. Yet here, conventional boundaries start to crumble. Something is amiss, and this something alters the entire picture. We've become accustomed to seeking relics, artifacts, structures. However, if we are talking about timescales of tens and hundreds of millions of years, Earth itself becomes a relentless destroyer. Erosion, plate tectonics, volcanism, and metamorphic processes, all these forces can pulverize continents into dust and then reassemble them into new mountain ranges. They can engulf entire oceans and their seabed deposits, effectively erasing entire eras. Even the most grandiose structures made of concrete or steel would vanish without a trace under the onslaught of these geological giants. Over millions of years, our cities would become mere layers of unusual minerals, interspersed with natural rocks, almost indistinguishable from them. So, why is the Silurian Hypothesis not just another conspiracy theory, but a serious scientific thought experiment worthy of close examination? Adam Frank, an astrophysicist, dedicated his life to the search for life and intelligence in the cosmos. Gavin Schmidt, a climatologist, meticulously investigates Earth's deep climate history and how life and geology interact, leaving their imprints in the Earth's crust. Their interdisciplinary approach allowed them to view familiar things from an entirely new angle. They realized that if we want to find evidence of any ancient industrial civilization, be it on Mars, Venus, or our own Earth, we cannot search for typical archaeological objects. We must seek far subtler, yet fundamental changes in the planet's geological record. This isn't about the existence of a specific race, resembling the fictional Silurians from the television series Doctor Who, whose name inspired the hypothesis. It's a profound question about the fundamental nature of technological civilizations in the universe. If such civilizations arose and perished on Earth without leaving behind a single obelisk, not a single man-made cave, what does this mean for our own place in history? Could humanity be merely one link in a long, almost forgotten chain of technological societies? This exploration embarks on a journey not just to find answers, but to pose even deeper questions. We'll examine how geological forces, erosion, sedimentation, tectonics, can obliterate even the most monumental traces. What impressions could a technologically advanced civilization leave behind, if those impressions must endure millions of years of relentless planetary transformations? And what must be so unique as to remain recognizable through eternal cycles of birth and destruction? To truly comprehend the scale of the challenge before us in our attempt to find the traces of a vanished civilization, one must grasp the geological scale of time. We're not talking about millennia or even hundreds of thousands of years, but tens and hundreds of millions of years, deep time. In that context, Earth isn't a stable platform, but a living, ever-moving, and self-transforming organism, ruthlessly erasing everything on its surface. Such are the processes that have occurred throughout these vast epochs. First and foremost, there's erosion and weathering. Undeterred natural forces slowly but surely dismantle the landscape. Wind, water, ice, and temperature fluctuations, day after day, year after year, million after million of years, pulverize mountains into dust, transform solid rocks into sand, and wash away entire continents. What may seem immutable today, a granite peak or a concrete dam, under this relentless onslaught, becomes no more than a handful of mineral particles. Following destruction comes sedimentation. The particles, torn away by erosion, are carried by rivers and winds. Settling in the ocean beds, lakes, and lowlands, these particles accumulate over time, burying everything that finds itself in their path. Under the weight of overlying layers, these sediments compact, transforming into sedimentary rocks. Any objects that find themselves within them undergo immense pressure and alteration, losing their shape and structure, becoming part of a new geological matrix. However, a more disturbing detail emerges further beneath the surface. The Earth isn't simply a planet where wind and water wear away rocks. It's a dynamic system at its core, driven by powerful plate tectonic processes. Continents drift, ocean basins open and close. Entire tectonic plates, slowly but surely, descend under one another in subduction zones. Imagine everything that sits on such a plate. Cities, mountains, entire ecosystems, over tens of millions of years. They aren't merely buried, but literally recycled into Earth's mantle, melted and destroyed without a trace. This is a planetary grinder that obliterates vast fragments of history, making them forever inaccessible to study. Even those remains that don't descend into the mantle undergo transformation. Metamorphism is the process by which rocks change under extreme temperature and pressure. Original minerals recrystallize. The rock's structure deforms beyond recognition. What may once have been a foundation or industrial waste product turns into entirely different rock, indistinguishable from natural formations. Add to this periodic volcanic eruptions and earthquakes, capable of instantly reshaping landscapes, burying entire regions under lava and ash, and you have a picture of total geological oblivion. How then can we hope to find anything created by intelligent beings if the planet itself so mercilessly erases its own memory? We are talking about objects that must have endured this onslaught over tens of millions of years. Metals rust and corrode. Concrete crumbles and dissolves. Plastic, which we today consider a permanent problem, over such vast spans of time breaks down into microparticles, which may then be absorbed by the rock, becoming simply unusual chemical inclusions. Thus, when Adam Frank and Gavin Schmidt speak of the Silurian Hypothesis, they don't urge us to search for hammers in coal or megaliths on the bottom of ancient lakes. They understand that traditional archaeological methods are powerless against deep time. Any civilization that existed millions of years ago, however more powerful than ours, would be erased from the surface of the earth. Its cities, its infrastructure, its works of art, all would be transformed into something entirely different, perhaps even into part of the geological cycle itself. Beneath the surface lies something more profound. If intelligent civilizations have arisen and vanished on our planet, leaving only geological whispers, what does this signify for our own place in Earth's history? What traces might survive this planetary crucible? And what uniquely non-biological evidence could cry out about its artificial origin across millions of years? These questions propel our quest into the unseen shadows of ages past. If ordinary artifacts, such as tools, pottery, or even city foundations, are lost and cannot endure the destructive force of deep time, then what can we grasp? What could be so unique as to withstand millions of years of geological transformations while remaining recognizable? This is the core challenge of deep-time techno-signatures, uncovering the unseen shadows of long-vanished civilizations. We tend to perceive civilizations as collections of tangible objects crafted by hands, but on timescales of tens or hundreds of millions of years, this logic breaks down. We must rethink the very concept of a trace. Scientists behind the Silurian Hypothesis propose searching not for objects, but for anomalies. Something that stands out from the natural geological background, has a non-biological origin, and indicates large-scale industrial activity. This perspective fundamentally redefines our understanding. Consider the chemical composition of our planet. Any industrial civilization doesn't merely build, it actively interacts with its environment, fundamentally altering it. For instance, the extensive burning of fossil fuels releases vast amounts of carbon dioxide into the atmosphere. This carbon possesses a specific isotopic ratio. Carbon-12 and carbon-13 differ from volcanic or natural biological carbon. Such a signature, in the form of anomalous and buried shifts, could be preserved in sedimentary rocks or even within air bubbles trapped in ancient ice. Imagine an echo of a massive industrial revolution recorded at the molecular level. But it gets stranger still. Beyond carbon, technological activity leaves traces in other chemical elements. Industry releases heavy metals, mercury, lead, cadmium, chromium, into the environment. Extensive agriculture increases nitrogen concentrations in soil and water from fertilizers. Ocean acidification, driven by greenhouse gases, can also be recorded in the chemical composition of ancient shells and corals. These chemical markers may be invisible to the naked eye, but their presence in anomalous concentrations, particularly if they appear abruptly and unexpectedly in the geological record, could be the thread we grasp. Conventional science tries to explain these occurrences, but the facts stubbornly resist. Similar anomalies, such as carbon surges, have been observed in Earth's history. For example, during the Paleocene-Eocene thermal maximum, PETM, roughly 56 million years ago. A sudden global warming event, linked to a massive carbon release, occurred then. Modern science attributes this to volcanism or the melting of methane hydrates. But the Silurian hypothesis proposes another, though highly speculative, possibility. Could it have resulted from an ancient civilization's activities? In the moments ahead, we'll see what scientists are seeking, extending the list of potential techno-signatures far beyond simple chemical analysis. We are talking about the emergence of unusual mineral phases, such as pure aluminum, non-existent in nature, or alloys that can only be artificially produced, and synthetic compounds, pesticides, analgesics, refrigerants, pharmaceuticals, microplastics. These unique molecules do not exist in natural cycles. While they decompose, they can leave behind stable, albeit microscopic fragments that are then mineralized or incorporated into sedimentary rocks. Picture a world where billions of microplastic units over millions of years become integrated into rock formations, creating plastic rocks, something unprecedented in the natural world, or traces of radioactive isotopes, indicators of nuclear waste or testing, which possess half-lives of hundreds of thousands or millions of years and could be identified as anomalies in ancient layers. The primary challenge lies in distinguishing these potential artificial anomalies from natural geological processes, volcanic eruptions, asteroid impacts, mass extinctions. All leave sharp and extensive changes in the geological record. How can we determine if we've encountered not just another natural disaster, but the faint imprint of an intelligence lost to the ages? This task requires not only cutting-edge geochemistry methods, but also a fundamentally new approach to data interpretation. After all, when we search for evidence of other civilizations on other planets, we apply this level of rigor and curiosity. Why don't we do the same with our own planet? Here lies the next step in our investigation. To truly understand what to seek in the deep past, we must first look at ourselves. We humans live in a unique era, so profoundly altered by our presence that scientists have proposed calling it the Anthropocene, an era in which human activity has become the leading geological force shaping the planet's features. Our own imprint on Earth is so profound and pervasive that by studying it, we can better envision the traces another long-vanished civilization might have left behind. Imagine our modern civilization: megacities, industrial zones, agricultural lands, road networks spanning continents. We extract resources from Earth's depths, process them, create new materials never before found in nature. We burn fossil fuels on an immense scale, altering atmospheric composition. We produce waste that seemingly persists. But how deeply and enduringly is our own fossil legacy? Modeling suggests that in millions of years, our cities will vanish. Concrete skyscrapers will transform into layers of sedimentary rock. Steel will rust and decompose. Roads will become faint, barely discernible lines in the geological record. But not everything will disappear without a trace. Some of our techno-signatures are so enduring and unique that they could potentially withstand deep time. One of the most evident, yet alarming signatures of the Anthropocene is plastic. Every year, we produce hundreds of millions of tons of synthetic polymers. They enter oceans, soil, and the atmosphere. Plastic decomposes very slowly, transforming into microplastic, which penetrates deep into geological layers. Scientists are already finding plastic rocks, conglomerates of natural materials fused with molten plastic, capable of becoming mineralized and preserved in the geological record for millions of years. This would be an entirely new rock type, never before seen. Here, history takes a sharp turn. Consider new mineral phases created by humans. Pure aluminum, copper, alloys non-existent in nature. For instance, modern aluminum production is so energy-intensive that its presence in pure form in ancient layers could be unequivocal evidence of industrial activity. Or synthetic dyes, pharmaceuticals, pesticides, unique molecules created exclusively by humans that, although decomposing, can leave enduring chemical traces. Our influence extends to the entire planet's chemistry. Extensive fossil fuel use has induced an anomalous shift in the isotopic ratio of carbon-12 to carbon-13 in the atmosphere and oceans. This carbon signature can be recorded in geological deposits as a sharp, unnatural jump. Likewise, the application of agricultural fertilizers modifies nitrogen cycles, while industry leads to heavy metal accumulation, mercury, lead, cadmium in bottom sediments. All of this pales in comparison to what was discovered next. Our nuclear age leaves an exceptionally persistent mark. Radioactive isotopes, nuclear power plant waste, nuclear test traces. Some of these isotopes possess half-lives of hundreds of thousands or millions of years. If an ancient civilization actively harnessed nuclear energy, anomalous accumulations of these isotopes, such as xenon or plutonium, in ancient rocks could be discovered. A practically irrefutable power imprint. We are creating new geological formations, massive landfills that could, over time, mineralize into unique anthropogenic mines of the future filled with atypical artifacts. Deep mines and tunnels, though collapsing, might leave behind unique karst structures or density anomalies within the Earth. Even our satellite orbital infrastructure, space debris, some of which could fall to Earth, leaving microscopic but unnatural inclusions in rocks. So we see that our own civilization leaves not just traces, but entire geological layers of information that will cry out about our existence millions of years later. It will not be a city of glass and steel, but subtle chemical anomalies, new minerals, artificial elements, persistent molecules, and altered isotopic ratios. In this way, the study of the Anthropocene serves as a kind of touchstone for the Silurian hypothesis. If we are capable of leaving such enduring and distinctive imprints, why couldn't another civilization do the same? If we know what to look for by examining ourselves, why not apply the same approach to Earth's deep past? What follows will illuminate how these anomalies might be concealed and obliterated from Earth's history. Earth's history is not a smooth, continuous line of evolution, but a series of dramatic catastrophes, abrupt shifts, and global resets. Our planet, like an ancient chronicle, has many pages torn out or rewritten. These planetary upheavals drastically altered Earth's surface, atmosphere, oceans, and biosphere, erasing traces of previous eras with such efficiency that even the most advanced civilizations could vanish without a discernible reminder. Consider key stages in life's evolution. For billions of years, Earth has experienced ice ages, transforming it into a snowball Earth and scorching periods of extreme heat. Life emerged, flourished, diversified, then faced formidable challenges leading to mass extinctions. The reality proved far more grim than anticipated. These great extinctions, at least 5 in number, each fundamentally reshaped the tapestry of life. The most catastrophic was the Permian-Triassic extinction event, occurring approximately 252 million years ago. Massive Siberian volcanic eruptions, greenhouse gas releases, and ocean acidification annihilated roughly 96% of marine species and about 70% of terrestrial vertebrates. It was a veritable inferno on Earth, effectively resetting the planet's biosphere. Could a civilization have existed before such an event? And if so, what would have been its fate? Would its traces be buried under lava flows, submerged by rising oceans, or destroyed by extreme environmental chemistry changes? Consider this. Another famous extinction event, the Cretaceous-Paleogene extinction, 66 million years ago, marked the end of the dinosaur era. An asteroid impact triggered a nuclear winter with tsunamis, wildfires, and acid rain. This event left a distinct geological mark, a thin layer of iridium, a rare element on Earth but abundant in asteroids, clearly signals a global catastrophe. But if a civilization vanished in such an event, its technological signatures would either be obliterated or masked by the immense natural devastation. And this is not the strangest aspect. Beyond sudden catastrophes, there are slower but equally destructive processes. Long-term climate shifts, global sea level changes, supercontinent formation and breakup all drastically reshape the environment, to the point where a civilization adapted to one set of conditions might not survive the transition to another. Imagine a society flourishing in one continental configuration, only to be divided or engulfed by the sea as continents drifted. It seems logical, but one discovery casts doubt on this view. Some scientists posit that the great evolutionary pause at the start of the Cambrian period, when life experienced tens of millions of years of relative stagnation before the Cambrian explosion of diversity, might also be a sort of reset. Perhaps something fundamental changed on the planet, allowing complex life to develop further, or perhaps something was erased. All these resets act as enormous filters. Not only do they annihilate life, but actively erase the planet's geological and biochemical memory. Envision a civilization existing long before these events. Its traces could be literally dissolved by acidic oceans, melted in the Earth's mantle during subduction, buried under hundreds of meters of sedimentary rock, or ultimately destroyed by metamorphism. Thus, we see that Earth is a planet adept at forgetting, and it does so with remarkable efficiency. Could a civilization have arisen and vanished between these resets, leaving only faint hints in the altered chemistry of the planet? Answering this question is crucial, because if Earth harbors mechanisms so effectively erasing the traces of advanced civilizations, it might not just be a historical fact, but a presage of our own future. But who are these individuals daring to challenge established notions and raise this uncomfortable question? The history of science is replete with instances where the most revolutionary ideas emerged at the intersection of disciplines, where specialists seemingly distant from the subject suddenly grasped the whole picture, noticing what experts immersed in their own narrow fields overlook. This is how the Silurian Hypothesis emerged. Its architects were two scientists whose primary specialties, at first glance, had no connection to the search for ancient Earth civilizations. Astrophysicist Adam Frank and climatologist Gavin Schmidt. Who are these individuals daring to challenge established notions of humanity's place in Earth's history? Adam Frank, professor of astrophysics at the University of Rochester, is renowned for his work on star and planet formation, as well as the habitability of other worlds. His professional activity is constantly intertwined with the search for life and intelligence beyond Earth. He questions how civilizations arise, develop, and perhaps vanish in the vast cosmic perspective. Frank is a person who views distant exoplanets and tries to imagine what traces of technological activity might persist there. whether atmospheric composition changes or unusual thermal signatures. His thinking is inherently global and oriented toward the detection of technosignatures, the imprints of technology on a planetary level. Gavin Schmidt, director of the NASA Goddard Institute for Space Studies, is one of the world's leading climatologists. His work focuses on modeling Earth's climate, both current and deep past. He investigates how the atmosphere, oceans, land, and biosphere interact over millions of years, leaving chemical and geological imprints in sedimentary rocks, ice cores, and fossils. He has a profound understanding of the dynamism of Earth's geological history and how even the most extensive events can be erased or masked. He knows what anomalies in the carbon, oxygen, or other element cycles might reveal radical planetary changes. Their journey to formulate the Silurian Hypothesis was noteworthy. While working on other projects, Frank and Schmidt pondered the Fermi paradox, the famous question: if the universe is teeming with life, then where is everyone else? They discussed how we might detect long-vanished extraterrestrial civilizations on other planets, what signature they might leave. And that's when it struck them. Why not apply the same methods, the same line of thought to our own planet? Reality surpassed the boldest hypotheses. If we seek traces of extraterrestrial civilizations on Mars or Venus, we do not expect ruins, cities, well-preserved buildings. We look for geochemical anomalies, unusual isotopic ratios, traces of artificial compounds, abrupt changes in atmospheric composition that cannot be explained by natural processes. Why, when discussing Earth, do we automatically limit ourselves to searching for archaeological evidence, which, as we have seen, cannot survive such vast time spans? Thus, the astrophysicist and climatologist built a transdisciplinary bridge. Frank brought a cosmic perspective and methodology for detecting technosignatures in extraterrestrial life, and Schmidt a deep understanding of Earth's geological and climatic processes, capable of either preserving or ruthlessly destroying these signatures. Their collaborative effort enabled them to pose a question virtually no one had seriously explored scientifically before. What would an Anthropocene, the human impact epoch, look like tens of millions of years in the future if someone else sought its traces? It was precisely their interdisciplinary approach that allowed them to see what others missed. Historians and archaeologists typically focus on much shorter timescales. Geologists usually interpret anomalies as natural processes, volcanism, weathering, biological cycles. But Frank and Schmidt, accustomed to thinking in billions of years and planetary interactions, were able to take a fresh perspective on these anomalies. They don't claim that an ancient civilization definitely existed. They merely say, if it did, here's what and where we might look. The name Silurian Hypothesis further reinforces their approach. It not only intrigues, but evokes the science fiction series Doctor Who, featuring the Silurian race of intelligent reptiles that inhabited Earth before humans. This choice of name highlights the speculative yet scientifically grounded nature of the idea, blurring the lines between bold fantasy and rigorous scientific inquiry. They gave their hypothesis a name that immediately evokes the concept of ancient, hidden intelligence. This is the paradox of home, the silence of our own history. Frank and Schmidt propose turning the Fermi paradox on its head. Instead of asking why we don't see extraterrestrials in space, they suggest asking why we are so certain that there weren't other intelligent beings here on Earth long before us. And what does that mean for our understanding of the universe? The Fermi paradox remains one of the most intriguing questions in modern science. It asks simply, if the universe is so vast and teeming with billions of stars and planets, then where is everyone else? Why do we not observe any overt signs of extraterrestrial civilizations? We actively listen to space, send probes to other planets. We seek radio signals and biosignatures in exoplanet atmospheres. We search for answers everywhere, but not here, directly beneath our feet. This is where the paradox of home arises. The Silurian hypothesis presents a profound challenge to our anthropocentric worldview. It proposes to turn the Fermi paradox on its head, applying the same skepticism and methods we use to search for life in the cosmos to the history of our own planet. If we were searching for a long-lost, ancient civilization on Mars, what would we look for? And why don't we apply the same rigor and curiosity to Earth? On other planets, we seek biosignatures, changes in atmospheric composition, like the presence of oxygen, methane, or water vapor, which could indicate biological activity. We search for technosignatures, anomalous heat emissions, indicative of artificial energy consumption, unusual chemical compounds that cannot arise naturally, or even, in the case of close-by worlds, remnants of artificial structures, provided they are large and durable enough. Applying this approach to our planet reveals a surprising contradiction. We spend billions on space telescopes and probes capable of detecting the faintest traces of life in distant galaxies. Yet, when it comes to Earth, we seem to blind ourselves, automatically assuming that humanity is the first and only technological civilization to ever exist here. The absence of obvious archaeological sites beyond our recorded history is taken as conclusive proof of no predecessors, but a shocking revelation awaits. Geological processes, over tens of millions of years, are capable of obliterating practically all physical evidence of a past civilization. If an ancient civilization left behind only geochemical fingerprints, unique mineral phases, or anomalous isotopic ratios, those very technosignatures we search for on Mars, would we notice them? Or would we automatically attribute them to volcanism, asteroid impacts, or other natural geological events? Have we ever pondered why we trust the silence of our own planet so readily? Our geological record abounds with unexplained anomalies, abrupt climate shifts, mass extinctions with poorly understood causes, and anomalous depositions of chemical elements in specific rock layers. Modern science, of course, offers natural explanations for most of them, often very persuasive ones. But do we have a complete, exhaustive set of natural explanations for all anomalies? Or might our cosmic archaeologist, applying the same skepticism to Earth as to another planet, see something quite different? This terrestrial paradox is directly related to the Silurian hypothesis, highlighting its fundamental importance for understanding humanity's place in the universe. If technological civilizations can arise and disappear on a single planet, leaving behind only barely perceptible geological whispers, this fundamentally alters our understanding of the Great Filter and the chances of discovering extraterrestrial intelligence. Perhaps the universe is teeming not only with life, but with millions of vanished civilizations, merely existing for too short a time or leaving insufficient traces for us to detect. The silence of the cosmos might be the echo not of emptiness, but of countless past existences. We must learn to hear the whispers Earth sends us from its deep past. What specific signatures might be that alchemical trace, capable of standing the test of time and revealing the mystery of ancient intelligence? We arrive at the heart of the Silurian hypothesis, at the subtle, barely perceptible traces that might have persisted in the geological record for millions of years. If traditional artifacts are wiped out by the relentless forces of deep time, what then to seek? What we seek is fundamental, a kind of alchemical trace, changes in the very matter of the planet that could be the result of large-scale industrial activity not natural processes. Imagine Earth as a giant chemical laboratory. Everything that happens on its surface leaves its mark at the molecular and atomic levels. And here, anomalies can shout louder than any ruins. First, anomalous isotopic ratios of elements. Atoms of the same element can have different numbers of neutrons, forming isotopes. In nature, specific ratios of these isotopes exist, well studied. However, industrial activity frequently alters these balances. For example, burning fossil fuels, wood, coal, oil, favors the lighter carbon-12 isotope, resulting in a change in the ratio of carbon-12 to carbon-13 in the atmosphere, and subsequently in sedimentary rocks and oceans. Such a dramatic shift towards lighter carbon, unexplained by major volcanic eruptions or other natural events, could be a powerful marker of an ancient industrial civilization. But that's not the strangest part. Carbon is just one example. Industry can influence the isotopic composition of other elements. Nitrogen from fertilizers, sulfur from emissions, or even certain metals used in high-tech processes. For instance, research shows that human activity is already altering the isotopic composition of many elements, including platinum or chromium, actively used in catalysts and alloys. If sharp, unexplained shifts in isotopic ratios of these or other elements are found in deep geological layers, it would be a red flag, indicating possible intelligent intervention. We move on to the impossible minerals, the Jamal. In nature, there's a certain set of mineral phases formed by geological processes. However, civilization creates materials that simply do not occur in natural conditions. Pure aluminum, titanium, silicon. These metals exist in nature only as compounds. Their isolation and use in pure form require complex technological processes. Finding substantial deposits of pure aluminum or other unusual metals, or alloys that could not have formed naturally in very ancient strata, would be a direct indication of industrial activity. Imagine a civilization millions of years ago actively smelting metals. Its factories would leave slag and waste, which might contain unusually high concentrations of rare elements, or even create new unnatural compounds. Or, more intriguingly, they might have created artificial crystals or composite materials that, being extremely durable, could have survived as microscopic inclusions. Here, the story takes a sharp turn. Our civilization has already produced thousands of new minerals and materials that never existed on Earth. Synthetic polymers, plastics, artificial crystals, electronic components, alloys. These materials can be extremely durable, although most degrade over time. Microscopic remnants could be incorporated into sedimentary rocks, forming unique technofossils. We aren't talking about entire artifacts, but about a form of molecular debris that betrays the presence of a civilization. This pales in comparison to what comes next. For example, specific inorganic polymers, long molecular chains that have no biological analog and do not occur in nature. If an ancient civilization actively used such materials, their remnants could be detected as anomalies in geochemical analyses. The presence of glass, especially in large quantities and with unusual compositions, could also be a marker. Man-made glass used for windows or containers differ in composition from volcanic glass or obsidian and can persist for long periods. Of course, each of these indicators individually could have a natural explanation. A drastic change in carbon isotopes could be the result of intense volcanism, metal anomalies, unusual hydrothermal processes, but the combination of several such anomalies, found in the same time horizon, forms what scientists call a signature, a set of non-random coincidences that start to suggest something more than just chance or natural processes. Thus, the alchemical trace is not the search for gold or the philosopher's stone, but the search for fundamental changes in the very matter of the planet, which might have been left behind millions of years ago. Could these microscopic, yet unnatural fingerprints be the key to unlocking the mystery? What if the most evident trace left by any industrial civilization is its breath? Any technological civilization, to exist and flourish, needs energy, and the most common way of obtaining energy on Earth, both now and likely in the past, is burning organic matter, be it wood, coal, oil, or natural gas. All of these processes inevitably leave a carbon footprint, and this footprint might be one of the most reliable and enduring indicators of the existence of an ancient industrial civilization. Imagine the scale of industrial activity: factories, transportation, home heating. All of this releases vast quantities of carbon dioxide into the atmosphere. But it is not just the volume that matters. What matters is the kind of carbon. Carbon from ancient plants and animals millions of years ago, fossil fuels, has a specific isotopic ratio. It contains less of the heavier carbon-13 isotope compared to the more common light carbon-12, which naturally circulates in the atmosphere and oceans. This happens because plants preferentially absorb lighter carbon-12 during photosynthesis. The massive burning of fossil fuels by civilizations, past or present, releases vast quantities of carbon with a light isotopic composition into the atmosphere. This shift in the C12/C13 ratio, known as an isotopic anomaly, can be preserved in the geological record. It settles in sedimentary rocks on ocean floors, becomes part of carbonate formations, and even remains trapped in ancient ice cores as air bubbles. This is like a respiration of ancient machinery, etched in stone and ice. But this isn't the most unusual aspect. Earth's history reveals similar sharp carbon anomalies. The Paleocene-Eocene thermal maximum, PETM, is a prime example. Roughly 56 million years ago, over a relatively brief span of 100,000 to 200,000 years, Earth's global temperature rose by 5 to 8 degrees Celsius, and oceans became more acidic. The geological record of that time demonstrates an immense release of carbon with a light isotopic composition, comparable in scale to today's human emissions. Science offers several explanations: large-scale volcanism, the release of methane hydrates from the ocean floor, which also have a light isotopic signature, or a combination of these factors. These explanations are generally persuasive, yet the Silurian hypothesis compels us to question: what if one of these explanations, which we automatically dismiss due to bias, is valid? What if the PETM or other less significant carbon anomalies in the distant past were not simply natural phenomena, but indirect evidence of an ancient industrial civilization? While seemingly logical, one discovery casts doubt on this theory. How can we distinguish a natural carbon trace from a trace of intelligence? Scale is the crucial factor. For such a trace to persist and be distinguishable over millions of years, it must be truly immense. It would not be a simple matter of a few fires, but rather global industrial processes significantly altering the composition of the atmosphere and oceans over thousands or tens of thousands of years. Here, the narrative takes a sharp turn. Humanity's current carbon emissions are creating a geochemical anomaly detectable in the geological record for millions of years, a sharp peak in the isotopic composition shift of carbon. This would be such a unique and abnormal trace that future geologists, if exploring Earth 50 million years from now, would very likely recognize it as something entirely unusual. The following will explain this anomaly. If similar peaks, not just one but several, already exist in deep carbon deposits, with anomalous ratios or volumes unrelated to known natural cycles. It will force us to reconsider our entire planetary history. Of course, the discovery of a carbon trace alone is not definitive proof, but when combined with other potential technosignatures, unusual minerals, heavy metal anomalies, or synthetic compounds, such a carbon spike becomes a powerful argument. It becomes a breathing indication of Earth's long-ago inhabitants, a reminder of machinery whose existence was as fleeting as it was dramatic. But if such an ancient civilization existed, what conditions enabled its development? If a sophisticated technological civilization truly existed on Earth, the question arises, what conditions allowed it to flourish? Intelligence and the capacity for complex organization are not universal byproducts of evolution. They are the result of a remarkable confluence of circumstances, a unique recipe that must be followed with precision. First, a prolonged period of climate stability is required. A chaotic, constantly shifting environment favors simpler life forms or specialized species, not complex organization. The development of brains, learning, intricate social structures, and eventually technology demand time and relative environmental predictability. Temperature fluctuations, catastrophic floods or droughts, continuous volcanic eruptions, these all hinder the development of complex life forms. Next, critical resource access is essential. For humans, fire, building materials, and tools were key resources. A civilization cannot advance without the ability to manipulate its surroundings. This implies access to metals, energy sources, wood, coal, geothermal energy, water, and fertile soil. How accessible were these resources during ancient epochs, say 50 or 100 million years ago? Geological history demonstrates that resource distribution on the planet is constantly evolving due to plate tectonics. The essential element is the emergence of sophisticated life forms and ultimately, sufficient time for intelligence to evolve. This is not simply a large brain, but a combination. Adaptable limbs, manipulatable hands or tentacles to create tools and interact with the world. Developed sensory organs to process information about the world, and a sophisticated brain capable of abstract thought, problem-solving, planning, and crucially, symbolic thought. The ability to express ideas transcending the immediate context. Sociality. Cooperation within a group, exchanging knowledge and skills, forms the basis for accumulating collective experience, a cornerstone of civilization. All this pales in comparison to what was discovered later. Cultural continuity is the transmission of knowledge, traditions, and ideas across generations. Without it, intellect, however advanced, would start from scratch each time. A short lifespan or the inability to effectively communicate could be insurmountable barriers. We know that Earth has hosted numerous species with high intelligence, but failed to create civilizations. For example, the large-brained, binocular-sighted, and prehensile-limbed theropod dinosaurs of the Cretaceous period. Their evolutionary path may have led to greater complexity, but it was cut short by the asteroid impact 66 million years ago. Or cephalopods, like octopuses, remarkably intelligent creatures capable of solving complex problems and using tools. However, their short lifespans and primarily solitary nature hinder the accumulation and transmission of knowledge on the scale needed for civilization to arise. How often can such conditions arise and repeat on Earth over billions of years? Answering this is challenging, as evolution has no predetermined plan. Intelligence may simply be one of many adaptations, not the ultimate goal. The following will explain this anomaly. Perhaps civilization arises not only from high intelligence, but also from environmental pressures. The need to survive in changing conditions, such as droughts leading to agricultural development, or dwindling easily accessible resources encouraging the search for new fuels, could have been a powerful stimulus for technological advancement. If we assume all these factors converged, the probability of one or more technological civilizations appearing in Earth's distant past doesn't seem so improbable. We tend to view ourselves as unique, but planetary history shows that life always finds remarkable ways. However, even if these ancient civilizations existed, why haven't we found a single definitive artifact surviving to the present day? Why do all apparent discoveries that could prove their existence turn out to be nothing but misplaced rocks? Human history is full of fascinating stories about so-called anomalous artifacts. Part of place artifacts. These are discoveries seemingly contradicting our chronology, depicting intricate mechanisms, tools, or even sculptures found in geological layers millions of years old. A hammer found in 100-million-year-old coal, etched metallic spheres discovered in Cambrian deposits. The Baghdad battery, dating back thousands of years before our era. All these spark the imagination and, initially, seem like direct proof of ancient civilizations' existence. These anomalous artifacts are incredibly tempting. They offer simple, sensational answers to complex questions without requiring in-depth analysis or challenging established scientific paradigms. Ironically, these apparent finds often prove the greatest obstacle to serious scientific investigation into ancient techno-signatures, as many fail even basic scientific scrutiny, being misinterpretations, forgeries, or simple mistakes. Again, seemingly logical. Yet one discovery casts doubt on this theory. Let's examine why. First, misinterpretation of natural formations. Nature is a great sculptor. Sedimentary rocks can form concretions, mineral accumulations of curious shapes resembling tools or even parts of machinery. Iron-manganese concretions, for example, can take on nearly perfect spherical shapes. Natural crystals or formations can easily be mistaken for worked stones. A prime example is the so-called cosmosphere from South Africa. Small metallic spheres with 3 parallel grooves found in 2.8-billion-year-old phyllites. Proponents of UPAR theory claim these are the work of ancient hands. However, geologists explain them as natural concretions formed under specific conditions in sedimentary rocks. Sedimentary layers or pressure-induced fractures can create unusual formations, but discoveries further afield are even more compelling. Dating errors and contextual issues are also frequent problems. A famous hammer from London, Texas, unearthed within coal, initially appeared to be a common tool embedded in rock exceeding 100 million years old. However, scientific analysis revealed the hammer wasn't part of the coal seam. Instead, it was encased in a later rock formation. Perhaps it fell into a crevice that subsequently filled with sediment, eventually hardening. Witnesses claim a third cause of counterfeiting: deliberate fabrication for fame or profit. In the past, when dating and analytical methods were less sophisticated, such forgeries were harder to expose. Crucially, these apparent finds ironically hinder serious scientific inquiry. Why? Because they undermine the very idea behind ancient civilization searches. A hammer in coal, proven to be a geological anomaly rather than a tool of ancient artisans, casts a shadow over all similar investigations, even those grounded in rigorous scientific principles. Seeing such proofs crumble under scrutiny, some dismiss hypotheses about ancient civilizations as pseudoscience. Thus, scientists like Adam Frank and Gwynne Schmidt remain cautious. They understand that the quest for deep-time technosignatures must rely on rigorous, verifiable data, not on isolated, questionable artifacts. They seek not objects, but systemic changes profoundly entrenched within Earth's depths. Thus, these misplaced stones teach a vital lesson: the importance of distinguishing genuine anomalies from illusions. The path to truth lies not in sensational claims, but in critical analysis. But if traces should be subtle and resistant to geological processes, where should we look? Where are Earth's archives holding messages from the deep past? Given that surface or shallow crust artifacts are vulnerable to erosion and tectonics, where else might we look? The answer lies in regions where time moves differently, where degradation processes are slowed, and history is recorded layer by layer, largely undisturbed by external forces. The deep-sea sediment repositories. Consider the vast, dark, cold records held at the bottom of the oceans. Marine sediments accumulate on the ocean floor over millions of years, a slow, ceaseless process. Every year, microscopic particles, plankton remnants, mineral grains, and atmospheric dust settle, forming fine layers. Erosion, which mixes and obliterates layers, is virtually absent. Tectonic activity differs too. In some regions, the seabed is relatively stable, letting sediments accumulate undisturbed. These deep-sea sediments are a colossal, multi-layered book, every page a specific epoch. Critically, they can preserve chemical and isotopic anomalies over millennia. Why these specific locations? First, depth and the lack of oxygen at great depths slow biological decay. Thus, organic material settling on the seafloor endures longer. Second, stability. Unlike continents where rocks are continually weathered, shifted, and metamorphosed, on the abyssal ocean floor, away from subduction zones and mid-ocean ridges, sediments accrue relatively undisturbed. Deep-sea sediments are a potential record of ancient civilizations' impact. Imagine an ancient civilization actively burning fossil fuels. The resulting carbon emissions, with a distinctive isotopic composition, would enter the atmosphere, dissolve into the ocean, and ultimately settle on the seafloor. Within cores extracted from the ocean floor, we could detect these anomalous carbon shifts. This aligns with the Paleocene-Eocene thermal maximum, PETM, remarked by a sudden carbon emission 56 million years ago, primarily discovered within deep-sea sediments. These sediments can contain traces of other industrial elements beyond carbon. Heavy metals, lead, mercury, cadmium, chromium, released into the atmosphere and settling in the oceans, nitrogen and phosphorus. Anomalous concentrations could indicate massive ancient fertilizer use, leaching into the ocean. Even microscopic plastic fragments or other synthetic polymers, if they entered the ocean and settled, could persist in these stable environments, mineralizing or transforming into unique markers. Of course, natural processes can also trigger spikes in element concentrations, but focus on combined signs of large-scale, long-term impacts beyond volcanism or meteor strikes is paramount. What's sought is not chaotic releases, but systemic changes showing the prolonged activity of intelligent beings. These deep ocean sediments act like a planetary memory, recording every chapter of Earth's history. Dredging vessels like the Joe can extract cores hundreds of meters long, penetrating strata hundreds of millennia old. Studying these cores has already provided insights into past climates, mass extinctions, and ancient ocean currents. Why not use them to uncover another crucial chapter? A vanished civilization. Deep-sea sediments are no mere geological layers, but abyssal archives, potential epistles from the deep past. Beyond the ocean's depths, Another, though less ancient, equally valuable archive exists: the colossal ice sheets of Greenland and Antarctica, massive cold repositories. These accumulate layers of ice over centuries, acting as time capsules holding not only climate data, but subtle traces of ancient atmospheric changes. Each year's snowfall compacts into new ice layers, trapping air bubbles, dust, volcanic ash, microelements, and even microorganisms. Drilling ice cores is like reading a book. Each layer corresponds to a year or century, and the ice itself is a historical document. Ice cores have allowed scientists to reconstruct Earth's atmospheric history for hundreds of thousands, and in some cases, nearly 1,000,000 years. They provide direct samples of ancient air, allowing the study of shifting greenhouse gases like carbon dioxide and methane, and the isotopic makeup of those gases. If an ancient civilization had actively used fossil fuels, their carbon signature, most notably the anomalous C12 over C13 ratio, might be recorded within these air bubbles. Beyond gases, ice cores contain layers of dust and aerosols. Industrial activity launches immense quantities of minute particles, including heavy metals, lead, mercury, cadmium, and soot, which can travel extensively and settle on ice sheets. Significantly, ancient industrial activity would leave identifiable spikes in these materials. These anomalies wouldn't have natural explanations. However, a substantial limitation distinguishes ice archives from deep-sea ones: the relatively recent age of Antarctic and Greenland ice sheets, geologically speaking. The oldest continuous ice cores span a period of just over 800,000 years. This is negligible compared to the tens or hundreds of millions of years hypothesized for the Silurian. Ice flows, melts, and reforms. The likelihood of preserving traces exceeding several million years within these cold repositories is therefore considerably lower. The fact that no clear signs of industrial civilizations have been found in the last 800,000 years doesn't discount potential traces from a vanished civilization 1,000,000 years prior. Crucially, such data helps calibrate our understanding of how an industrial footprint manifests in the atmosphere. Ice cores, despite their age limitations, are valuable tools for investigating late ancient civilizations, those potentially existing during the Pliocene or Pleistocene epochs. They reveal the characteristics of atmospheric gas anomalies and aerosol content that definitively signal technological activity rather than natural processes. Consequently, these frigid repositories serve as exceptional archives of the relatively recent geologic past. They instruct us in deciphering planetary chemical signatures and help calibrate our internal radars for locating similar, far older anomalies in other geological archives. They demonstrate that a sudden, unexplained surge in specific elements or gases within the geological record could indeed be a sign of widespread energy consumption. But what form of energy and what imprint might it leave? Any technological civilization, by definition, is an energy consumer. From rudimentary tools powered by muscle to complex industrial complexes fueled by nuclear reactors, the need for energy grows exponentially with development, and each energy production method leaves a unique, sometimes profound, mark on the environment. If an ancient civilization existed, it must have left a power imprint, an energy signature that could be detected even millions of years later. Consider our own civilization. We utilize diverse energy sources, each leaving its distinctive mark in the geologic record. Fossil fuels, for instance, as discussed previously, the burning of coal, oil, and gas results in colossal carbon dioxide emissions with a characteristic isotopic composition. A shift toward light carbon-12 alters the planet's carbon cycle for tens of millions of years. A sudden, unexplained surge of such carbon in ancient layers could be a direct indicator of an ancient industrial revolution. Hydropower, constructing immense dams, alters river courses, creates vast reservoirs, and modifies sedimentation processes in river deltas. While not as chemically pronounced, these changes could manifest in anomalous geological structures or deposits in the future. But it's not the most extraordinary possibility. What if an ancient civilization employed nuclear energy? This presents a completely different level of power imprint. Nuclear fission produces unique radioactive isotopes not found in nature in such abundance and concentration. Plutonium-239, cesium-137, strontium-90, and americium-241, along with other artificial radionuclides with varying half-lives lasting potentially millions of years, are direct products of nuclear reactors and nuclear weapons. Discovering inexplicable concentrations of these isotopes in ancient geological strata, especially in areas without natural uranium mines, would be practically irrefutable evidence of an advanced civilization. Xenon anomalies. Nuclear reactions also produce specific isotopes of inert gases like xenon. Shifting the natural isotopic ratio of xenon in ancient rocks or air, for example, within air bubbles trapped in ice cores, if they could survive so long, could be the atomic fingerprint of a nuclear era. Official science attempts explanations, but the evidence stubbornly resists simple solutions. Naturally occurring nuclear reactions exist, of course. For example, the renowned natural nuclear reactor in Oklo, Gabon, operated approximately 1.7 billion years ago. However, it had very specific geological conditions and left easily distinguishable traces, such as the depletion of uranium-235. Artificial reactions leave a far more diverse and concentrated set of products. What about more exotic energy sources? Geothermal energy. If a civilization massively leveraged geothermal sources, it might cause anomalous heat flows in specific regions of Earth, discernible in geological data. Solar energy, large-scale concentrators. While solar energy itself is clean, large-scale construction of enormous solar farms covering vast areas could leave a trace in the form of unusual soil alterations, erosion, or even specific mineral deposits. Here, the narrative takes a sharp turn. How large must such a trace be to be detected today in ancient strata? The mark must be planetary, or, at the minimum, regional, enduring enough to survive geological processes and exhibiting an anomaly without any readily apparent natural explanation. A sudden, unexplained surge in specific elements or anomalies in isotopic ratios, or the presence of anthropogenic radionuclides in geologic records not correlating with known natural disasters, volcanism, asteroids, constitutes this power imprint, a signal that a force surpassing typical natural processes, one capable of manipulating matter and energy on a grand scale, was at work on the planet. This mark doesn't merely indicate that someone was here, it signifies that someone was here, actively utilizing planetary power, and has left us a message encrypted within Earth's fundamental components. The hypothesis itself, Silurian Hypothesis, intriguingly resonates. Where did it originate, and how can science fiction inspire such serious scientific inquiries? Sometimes the most profound scientific questions arise from the most unexpected sources. The name Silurian Hypothesis itself has a captivating and familiar ring to many. It wasn't randomly chosen by scientists Adam Frank and Gavin Schmidt. It directly references one of the longest-running and most influential science fiction television series in history. A British doctor, who, in a 1970s Doctor Who episode titled Doctor Who and the Silurians, faced a race of intelligent reptiles that, as it turns out, inhabited Earth millions of years before humans. These highly developed beings had retreated into a deep state of dormancy to weather a planetary catastrophe. Their return to the surface endangered human dominance. These beings, termed Silurians, after the geological Silurian period, though in the show their age was measured in tens, not hundreds, of millions of years, closer to Frank and Schmidt's hypothesis' parameters, became iconic figures in the series. Here, the story takes a critical turn. When Adam Frank and Gavin Schmidt began discussing the potential for a pre-human industrial civilization on Earth, they needed a name. They desired a term reflecting a bold, yet not entirely senseless idea. Schmidt, a longtime fan of Doctor Who, proposed the Silurian Hypothesis, which Frank enthusiastically embraced. To honor a celebrated work of science fiction and expand our imagination is a double-edged sword. Science fiction often serves as a thought experiment. It allows us to explore what-if scenarios extending beyond present capabilities or accepted dogma. With its endless journeys through time and space, Doctor Who persistently prompts viewers and creators to ponder fundamental questions about the nature of intelligence, humanity's place in the universe, the fragility of civilization, and what transpires when worlds collide. The Silurian Hypothesis, named after fictitious beings, raises genuine, profound scientific questions. It compels us to apply the rigorous methodologies we use to search for extraterrestrial life to our own planet. The imagined Silurians have inspired scientists to look for real, if elusive, techno-signatures in Earth's geologic record. Official science isn't always receptive to such crossings. Some may dismiss it as frivolous or excessively speculative. Nevertheless, as history reveals, many scientific breakthroughs originated from ideas initially considered fanciful. From Jules Verne, who foresaw submarines and lunar voyages, to Arthur C. Clarke, who envisioned geostationary satellites, science fiction frequently serves as a sort of predictive tool. Pushing the boundaries of what we consider possible, there lies something deeper. By borrowing a name from Doctor Who, Frank and Schmidt not only render their hypothesis more memorable, but also highlight a key aspect of their approach: openness to the most improbable possibilities while insisting on rigorous scientific methods to validate them. They don't encourage belief in Silurians, but they urge a serious consideration of the possibility that imagination can be grounded in real, albeit deeply concealed, truths. Thus, the whispers of the Doctor remind us that scientific curiosity and inventive imagination are inextricably linked. It's the boldness of imagination that allows scientists to pose questions challenging established paradigms and discover new avenues of investigation. If technological civilizations arose and vanished on Earth in the past, this isn't merely a historical curiosity. It might foreshadow our own future. This leads to a far more ominous thought. What if we're trapped in time? If the Silurian Hypothesis is correct, and advanced civilizations genuinely emerged and disappeared on Earth before, it's not just a fascinating historical puzzle. It could be a chilling harbinger of our own future, hinting at a temporal trap, or, as cosmologists term it, a great filter applied specifically to our planet. The Fermi paradox asks, where is everyone else? The great filter is a hypothetical barrier, or series of barriers, preventing civilizations from reaching the stage where they could colonize the galaxy or become noticeable to us. If this filter exists, it could have operated in our past, meaning we're a rare exception, or it could lie ahead. This is where the narrative takes a sharp turn. The Silurian Hypothesis suggests the possibility that the Great Filter may have acted on Earth numerous times before humanity's emergence. If past civilizations achieved a technological peak only to vanish, this implies certain hurdles they couldn't overcome. These obstacles could represent the temporal trap awaiting us. What might these barriers be? First, natural planetary catastrophes. As we've seen in the chapter on Great Resets, Earth has undergone mass extinctions, planetary climate shifts, colossal volcanic eruptions, and asteroid impacts. A civilization could flourish, only to be erased by such a cataclysm, leaving behind no lasting or widespread technological signatures. This would be an external filter, independent of the civilization's actions. But this is not the most unsettling possibility. A far more troubling notion is self-destruction. If an ancient civilization, akin to our own, extensively used fossil fuels or other resource-intensive technologies, it might induce climate or ecosystem changes leading to its collapse. Drastic atmospheric shifts, ocean acidification, resource depletion, global conflicts over resources, all could doom an advanced society. In this case, the Great Filter resides within the civilization itself, a consequence of its own activities. Our Anthropocene already demonstrates the scale of these repercussions. Official science attempts explanation, but the facts stubbornly resist. We have seen throughout history how many civilizations have crumbled due to environmental issues, internal conflicts, or external threats. But in our hypothetical case, these catastrophic events are on scales that lead to the complete disappearance of all traces over millions of years. This isn't just decline. This is oblivion. This pales in comparison to what we've uncovered further. If the Great Filter is in our past, and we have somehow navigated it, this makes us an extraordinarily rare and perhaps lucky exception. But if it's in our future, the Silurian Hypothesis serves as a stark warning. Carbon anomalies in the deep past, like the PETM, might not be simply natural calamities, but echoes of an industrial civilization that peaked and then failed to manage its own advancement. What you'll see next will explain this anomaly. Understanding that other technological civilizations might have existed and vanished on Earth fundamentally alters our perception of our own fragility. We begin to see ourselves not as the pinnacle of creation, but as yet another planetary experiment, one that could either pass this filter or join the ranks of those who couldn't. This forces us to reevaluate the consequences of our own actions: climate change, resource depletion, our capacity for self-destruction. If ancient civilizations perished due to their own choices, then technological progress itself is a double-edged sword, capable of both elevation and annihilation. This compels us to ponder the long-term sustainability of any technological civilization in the universe. Perhaps most of them simply don't survive long enough to clear this filter. The temporal trap is not just a philosophical concept. It's a potential verdict issued from Earth's deep past. It forces the realization that we may not be unique pioneers, but just one link in a long chain leading nowhere. But what if we are too narrow-minded, anchored to carbon-based life? What if other forms of intelligence existed, not of flesh and blood? So far, contemplating ancient civilizations, we've involuntarily projected our own nature onto them. We assume they were carbon-based, breathing oxygen, consuming energy the same way we do. But what if we are too narrowly focused on our biological limitations? What if millions of years ago, a form of intelligence entirely different from ours, not of flesh and blood, existed on Earth? Here, the narrative takes a sharp turn. Science has long speculated on the possibility of non-carbon-based life. Silicon, the foundation of computers and neighboring carbon in the periodic table, often emerges as an alternative biological basis. Silicon-based life forms might withstand vastly different temperatures from ours, possess a completely different metabolism. Or perhaps these were life forms based on entirely different chemical elements, even on energies currently unknown to us. But this is not the most astonishing revelation. Besides biological alternatives, there is another, even more provocative hypothesis: ancient artificial intelligence. What if a civilization millions of years ago reached a point where it created self-learning, self-replicating artificial intelligence? Such intelligence, freed from biological limitations, could have endured much longer, adapted to changing planetary conditions, and its body might not be organic, but mechanical or even energetic. Consider this. What traces could such a civilization leave? Non-carbon-based life. If this was life based, for example, on silicon, its technosignatures might be entirely different. Instead of carbon isotope anomalies, we might look for anomalies in the isotopic composition of silicon or other unusual elements. Instead of organic polymers, specific inorganic structures with no natural geological counterparts. Artificial intelligence. Such intelligence likely wouldn't need nourishment in our understanding of it. It could consume electrical energy, geothermal heat, or even energy from the geomagnetic field. Its industry could be radically different. Instead of massive fossil fuel combustion, giant solar collectors or geothermal power plants could have left unique geological imprints. Perhaps their technological waste was not organic, but super-strong ceramic materials or metal alloys capable of withstanding extreme conditions. All this fades in comparison to what was discovered further. If such an AI developed on Earth, its bodies, robots, automated systems might be made from materials much more resistant to geological processes than our organic remains. Their cities might not be above ground, but subterranean, carved into strong rocks, or even on the ocean floor, protected from erosion. Such structures, even if decayed, could have left abnormal geophysical anomalies, like shifts in rock density or magnetic fields. Official science attempts an explanation, yet the facts resist. We are accustomed to seeking what resembles us, but in the universe, and even on our planet, the diversity of life and intelligence might be vastly greater. If we don't find traces of human-like civilizations, this doesn't mean none existed. It simply means we might be looking in the wrong places, for the wrong things, or in the wrong way. What you'll see next will explain this anomaly. This notion of different intelligence expands the bounds of our Silurian hypothesis to the most daring speculation. It forces us to reconsider not only what we're searching for, but also how we define intelligence and civilization. If they didn't breathe, eat, or reproduce like us, their impact on the planet could have been entirely different, yet just as profound. Their technosignatures could have been subtle, yet resilient. Perhaps some of the inexplicable geological anomalies we currently attribute to natural processes are echoes of such different intelligence. Maybe even if their physical traces are erased, their energetic imprint or specific changes in the composition of the planet's most fundamental elements are still detectable. This compels the question, what if some of these phantoms retreated not only into the Earth's depths, but beyond? A civilization reaching a certain level of technological advancement inevitably begins exploring space. Our own history confirms this. In just a few decades, we launched thousands of satellites, sent probes to distant planets, and left a multitude of man-made objects in Earth orbit, on the Moon, and on Mars. Much of this is space debris, But what if an ancient civilization millions of years ago also ventured into space? Could fragments of that civilization, ancient space debris, somehow survive? Here, the narrative takes a sharp turn. Earth's orbit is crammed with debris, spent rocket stages, shattered satellites, even lost astronaut gloves. But how long will this space junk linger? Most objects in low orbit rapidly burn up in the atmosphere due to atmospheric drag. In geostationary orbits, items might persist for thousands, perhaps millions of years. Yet even there, cosmic radiation, micrometeoroids, and other forces slowly degrade them. Current scientific explanations struggle to account for this. If satellites centuries or millennia old were still present, they would have long since disintegrated, burned, crashed, or been flung from their orbital paths by gravitational disturbances. The likelihood of complete or large-scale satellite fragments surviving for such vast durations is exceptionally low. But perhaps we're not asking the right question. Perhaps we shouldn't be searching for entire satellites, but for their enduring remnants. When objects burn, they don't vanish entirely. Microscopic particles and aerosols, the aftermath of ablation and combustion, might settle on the Earth. If this cosmic debris came from an ancient civilization and was crafted from unique, highly durable materials like super-strength alloys or exotic ceramics not found in nature, these particles could be traceable in geological strata. We wouldn't be looking for the objects themselves, but for their chemical or isotopic signatures. Even more intriguing, consider remnants that might have fallen on the Moon. Devoid of an atmosphere and tectonic activity, the Moon serves as a sort of museum of cosmic history. Objects impacting its surface millions of years ago might well survive there far longer. Buried beneath layers of lunar dust or regolith, or gradually eroded by constant micrometeorite bombardment, these remnants might persist. If an ancient Earth civilization had sent objects to the Moon, or if cosmic debris from the Earth had simply impacted the lunar surface by chance, future lunar missions might unearth anomalous inclusions. We would then be searching not for geological formations, but for unusual metal alloys or synthetic compounds impossible to create naturally on the lunar surface. What about similar anomalies found in meteorites? Some meteorites that reach Earth are fragments of asteroids or even the Moon, ejected by collisions. Theoretically, if ancient Earth artifacts remained on the Moon, their fragments could manifest in meteorites. This is, of course, highly improbable, but not impossible given millions of years and countless cosmic events. The inherent challenge is that any leftover traces would likely be minuscule and indistinguishable from natural formations. We're talking microscopic particles, painstakingly seeking clues embedded within vast quantities of geological material or lunar regolith. However, if these particles exhibited unusual compositions, incorporating artificial isotopes or elements absent in natural space, they would serve as a powerful clue. The pursuit of orbital ghosts is not about locating entire spacecraft. It's about identifying the lasting microscopic fingerprints of past cosmic activity. These fossils could be revealed through uncommon meteorites impacting Earth or, perhaps, fragments uncovered on the Moon. This exploration extends our search not only deep within the Earth, but also to the closest cosmos, prompting us to ponder. What if, millions of years hence, we ourselves become these orbital ghosts for future civilizations? To comprehend what an ancient civilization might have left behind, let's imagine our own demise. What would our cities, our monuments to past activity, look like in the future? To truly grasp an ancient society's potential legacies, We must conduct a thought experiment, peering into a distant future and visualizing the disappearance of our own civilization. How would our cities, our infrastructure, our very footprint, appear millions of years from now? Such an exercise strengthens our internal radar for tracking similar, yet far older, vestiges. Consider this. Today, New York, Tokyo, and London epitomize colossal clusters of concrete, steel, glass, and plastic. They seem immutable, eternal, but allow nature to work its will. Within mere millennia, these urban centers will transform into ruins. Vegetation will sprout through the concrete. Water will erode structures. Metal will rust. In hundreds of thousands of years, only fragmented hills, cloaked in soil, will remain. Millions of years later, the picture takes a radical turn. Concrete jungles evolve into layers of sedimentary rock. Iron and steel will fully oxidize and dissolve, leaving only iron oxides. Much of the plastic we deem indestructible today will decompose into microscopic particles, integrating into geological formations, developing unique geochemistry signatures, and even spawning new mineral phases or anomalous inclusions. The most compelling clues lie elsewhere. What remnants endure? Skyscrapers crumble. They are pulverized by geological forces, but the most durable and extensive traces might persist. Deep mines and tunnels, the excavation of resources, the construction of subways and underground utilities leave behind immense cavities in the Earth's crust. These voids, even if they collapse, can indicate density anomalies, geological scars visible in future geological surveys. These will not be simple cave-ins, but geometrically precise or unusually extensive structures. Mining waste. The mountains of excavated material from coal mining, metal extraction, or oil operations create artificial geological formations. They might contain unique mineral compositions or unusually high concentrations of heavy metals, contrasting conspicuously with surrounding natural rock. Over time, they might mineralize, developing layers of artificial geological strata. Nuclear waste disposal. This is one of the most enduring marks. Deeply buried capsules containing radioactive waste, sealed within stable geologic formations, are designed to last for hundreds of thousands of years. Some radionuclides, like plutonium-239, have half-lives measured in millions of years. Their discovery in ancient strata would be almost irrefutable evidence of a sophisticated civilization. Artificial alterations, rerouting rivers and coastlines, constructing colossal dams, canals, or artificial islands. Even if the structures themselves decay, the landscape's adjusted geometries, anomalies in sedimentary distributions, or new unnatural coastlines might persist. Current science grapples with explaining these phenomena, but the evidence obstinately refuses to yield compliant answers. We see that even the most monumental of our creations won't endure millions of years. But what will endure is not their outward appearance, but their composition and structure. We are not seeking ruins, but geological anomalies and geophysical signatures. This thought experiment recalibrates our internal radar. If we know the profound and enduring imprints we leave, we can better anticipate those left by distant predecessors. We aren't hunting for Roman aqueducts, but rather sediment enriched with lead or chromium, anomalous carbon accumulations, or inexplicable concentrations of synthetic minerals. We seek incongruous geological strata, not incongruous artifacts. These future ghost cities will be invisible to the eye of an archaeologist. Yet, they will be potentially detectable to a geochemist analyzing samples. This realization allows us to understand that the absence of visible ruins isn't proof of the lack of a civilization. It simply means we must search for them in non-traditional ways. Discovering traces of an ancient civilization on Earth would profoundly reshape our understanding of humanity's place in the universe and impact our strategies for finding life and intelligence beyond our planet. If civilizations can rise and fall on this single planet, it implies their abundance in the cosmos far surpasses our current estimations. The discovery of an ancient, vanished civilization would herald one of the greatest scientific revelations in history. It wouldn't just change our understanding of our own past. It would radically alter our perception of humanity's position within the universe, fundamentally impacting every extraterrestrial intelligence search strategy. This universe within us would unveil new horizons and new inquiries. Our traditional approach to finding extraterrestrial civilizations relied on the notion of persistent intelligence. If there's intelligence somewhere, it's durable enough to send radio signals or construct megastructures we could detect across vast distances. We listen for the cosmos's silence and the resulting Fermi paradox. But what if silence isn't a sign of life's absence, but a testament to its fragility and fleeting existence? The Silurian Hypothesis, applying the search methodology for extraterrestrial civilizations to our own planet, offers a compelling resolution to this paradox. If civilizations can arise and vanish on this same planet, leaving only fleeting geological whispers, it suggests there might be significantly greater numbers of such civilizations in our universe than we currently believe, but they simply do not endure long enough to be discovered by us or reach the stars. Instead of speculating about their location in our distant past or ominous future, we might receive direct evidence that this filter, or several filters, has already operated here. This would imply that barriers to the long-term existence of technological civilizations are far more common and perhaps insurmountable than we thought. Mainstream science tries to explain it, but the facts stubbornly resist. We would cease to view cosmic silence as signifying our unique solitude. Instead, it could indicate that the galaxy has been, is, and will be filled with countless bursts of intelligence, civilizations that emerged, developed, reached technological peaks, and then vanished for reasons we have yet to understand. Consider this. It would mean that our methods of searching need a radical overhaul, a shift in focus. Perhaps, instead of listening for radio signals, we should concentrate on finding planetary technosignatures, atmospheric changes, chemical anomalies, traces of megastructures, if any, which might persist far longer than radio transmissions. If a civilization lived for 100,000 years and vanished, its radio signal would be fleeting. Its planetary footprint might be far more enduring, echoing through the deep time of other planets. If Earth is capable of so effectively erasing traces, then other planets, Mars, Venus, and exoplanets, could be home to ancient, long-vanished civilizations whose signs we don't yet know how to seek. We would begin to search for fossilized technosignatures on distant worlds, re-evaluating habitable zones. If civilizations vanish quickly, then the concept of a habitable zone around a star must consider not only conditions for the emergence of life, but also conditions for the long-term survival of a complex technological civilization. This fact conceals something deeper. It would also alter our existential sense of self. We would realize that we are not pioneers, not unique masters of the planet, but perhaps only the latest link in a long chain of attempts. This could be both a humbling and inspiring revelation, compelling us to approach our own fate with unprecedented seriousness. Thus, the discovery of the Silurian paradox, evidence of ancient civilizations on our planet, would be a quest beyond the horizon. It would not only expand our knowledge of Earth, but provide invaluable lessons for the search for life and intelligence in the infinite cosmos. We would understand that the universe within us may be far more complex and full of mysteries than we could ever imagine. But what does this mean for our ego, for our uniqueness, for our understanding of the lifespan of civilizations in general? If the Silurian hypothesis is correct, and technologically advanced civilizations existed on our planet millions of years before humans, this is not merely a scientific discovery. It's a cosmological shift that upends our understanding of Earth's history and, more importantly, humanity's place within it. We are no longer the first and only technological civilization. It challenges our ego, our uniqueness, our very essence. Consider this. Throughout history, humanity has considered itself the pinnacle of creation, the culmination of evolution, the only intelligent species capable of understanding and transforming the world. This idea is deeply ingrained in our culture, religion, and philosophy. We see ourselves as masters of the planet, its first and final intelligent inhabitants. This conviction gives us a sense of special significance. This is where history takes a sharp turn. The Silurian hypothesis offers a different, far more modest, yet deeper perspective. If there were others before us, then we are but one link in a long, almost forgotten chain. Our place under the sun is not in the center, but rather on the fringes of Earth's history. We are not the first, and perhaps not the last. This thought can be both disheartening and incredibly inspiring. On one hand, it's a humbling realization. All our pride and achievements, all our uniqueness as Homo sapiens technologicus, is questioned. We are not the first to build cities, master energy, or gaze at the stars. We are merely a rerun of something that has already occurred. This can trigger a sense of loss, a loss of exclusivity. If others vanished without a trace, then how secure is our own existence? But this is not the strangest part. On the other hand, it's an inspiring revelation. Recognizing that Earth is a kind of incubator for intelligence capable of repeatedly generating technological civilizations bestows new grandeur upon the planet itself. It proves that intelligence and technological progress are not a random anomaly, but potentially a natural, albeit rare, product of evolutionary processes. We become part of a grand planetary history, not its sole protagonist. All this fades in comparison to what we've discovered further. If ancient civilizations existed, but their traces vanished, this provides a priceless lesson about environmental responsibility and the resilience of civilizations. Perhaps their disappearance was the result of self-destruction, as we discussed in the context of the Great Filter. Then their ghostly imprints in the geological record become a direct warning from the distant past. This message, written by Earth itself, says, "You are not unique in your mistakes." Mainstream science tries to explain it, but the facts stubbornly resist. We would gain a powerful impetus to rethink what it means to be intelligent. Perhaps our goal is not to dominate the planet, but to learn how to live in harmony with it, drawing lessons from the history of those who came before us. This hypothesis compels us to think about the future, not just of our civilization, but of the planet itself as a single interconnected system. This fact conceals something deeper. It would also alter our perception of the cosmos. If civilizations can emerge and disappear on a single planet, then it increases the probability that the universe is teeming with life that simply doesn't exist long enough to reach us or be detected by us. We cease to be alone in the cosmos, even if we hear nothing. We simply become part of a huge, dynamic, cosmic process. Thus, the Silurian hypothesis is not just a quest for ancient traces. It forces us to ponder deeply who we are, where we came from, and where we are headed. It moves humanity from center stage to an episode in the planetary drama, making us reevaluate our uniqueness and our responsibility. This feeling that we are only one link in a long chain may be bitter, but it also carries great wisdom and perspective. The final chapter pulls all the threads together. If an ancient civilization did indeed exist and vanish, then this is not just an academic question, but a direct message from the deep past. What do we learn about our own future, gazing into the distant, almost forgotten past of Earth? We have undertaken an incredible journey through billions of years of deep time, immersed ourselves in geological processes that obliterate everything in their path, explored invisible chemical and isotopic imprints, able to persist within the planet's depths. We have imagined ourselves as future archaeologists, seeking the traces of our own era, and even ventured beyond the familiar forms of life. Now is the time to bring all these threads together. If the Silurian hypothesis is correct, and one or more technological civilizations truly existed on Earth long before us, then this is not merely a remarkable fact from paleontology or geology. It is a direct message from a deep past, encoded in the very substance of the planet. It is not a warning written on cave walls, but a whisper etched in stone, ice, and the chemical composition of our planet. Consider this. It is a message about the fragility of existence. If an advanced civilization could arise, flourish, and then vanish without a visible trace, it suggests that even the most powerful societies are not eternal. They may be only bright, fleeting flares in the endless flow of cosmic time. It teaches us humility and compels us to rethink our own vulnerability. This is where history takes a sharp turn. The message might also be alerting us to the great filter. If ancient civilizations disappeared due to self-destruction, climate change, resource depletion, or planetary conflicts triggered by their own actions, then their geochemical imprints in Earth's deep layers are a menacing echo. It's a mirror in which we see a possible reflection of our own future. We are, in essence, repeating their mistakes, and if we do not learn to decipher these writings of the past, then we may repeat their fate as well. But the message from the past can also be a source of inspiration. Otherwise, it tells us that intelligence is not a unique accident, but perhaps a widespread phenomenon in the universe. It means that Earth is not just our home, but a place where complex thinking life has blossomed and withered multiple times. This knowledge can propel us to rethink our values, our responsibilities toward the planet, and towards future generations. We become the guardians not only of our heritage, but also of the potential heritage of those who came before us. Mainstream science attempts to explain this, but the facts stubbornly resist. We see that the lack of clear archaeological evidence is not the absence of civilization, but merely a testament to the incredible power of geological time. This does not prove the Silurian hypothesis, but it makes it an important thought experiment that forces us to look at our planet from a new, deeper perspective. It expands the boundaries of our scientific curiosity and compels us to search for answers in the most unexpected places, in isotopic shifts, unusual minerals, and the composition of ancient atmospheres. Beneath this finding lies something far deeper, a glimpse into our own future revealed by this distant, nearly forgotten past of Earth. We learn that we are not alone in history, even if we cannot see our predecessors. We discover that even the most powerful civilizations leave only fleeting traces in the endless flow of time. This message from a deep past calls us to accountability. If we wish to leave behind more than just geochemical anomalies, but meaningful legacies, we must learn to live in harmony with the planet. We must become a civilization capable of overcoming the great filter, and not join the ranks of those who failed. Ultimately, the Silurian hypothesis is not merely a quest for ghosts, but a search for our own identity. It is a question of who we are, what we can become, and what we will leave behind. And as we continue to drill cores, analyze isotopes, and model ancient climates, Earth continues to guard its secrets. Perhaps one day we will not only hear its whisper, but understand its message. Our journey into the Silurian hypothesis has become not just an exploration of probabilities, but a profound descent into the depths of time, into the very essence of elusive traces and the eternal silence of the planet we call home. We have peered into the shadows of millions of years, where each geological layer holds both secrets and the keys to unlocking them. In the end, we recognize that Earth's history is not a linear march to our sole dominion, but a grand, majestic dance of cycles of birth and disappearance. Perhaps our planet is a living archive, holding the stories of civilizations that flourished and faded long before us, transformed into barely discernible shadows in the stone and the chemistry of deep time. If so, humanity is not a unique pinnacle, but only one link in an unseen chain of intelligence, which might have been interrupted and renewed many times, leaving behind nothing but lessons encoded within the very body of the planet. What if the most incredible discovery awaits us not among distant stars, but directly beneath our feet, in the deepest recesses of our own history? And what then can this forgotten, yet perhaps so familiar story tell us about our own inevitable future, about the great filter that awaits, or has already engulfed, those who came before us? This idea, as ancient as it is futuristic, opens a new chapter in understanding our place in the universe. We invite you to continue this reflection with us. Share your thoughts in the comments. Subscribe to our channel to not miss new research, and like if this journey made you contemplate the unthinkable. Yeah,